Good everyone, welcome to Tutors. And today's episode, we're going to look into another question, and we're going to try to see how to qualitatively interpret it. Looking for first, qualitative interpretation involves you even able to like estimate. Okay, what can be the depth of our metallic body be? What is the depth quantitatively without even really like solving and doing all manner of inversions and the rest? Now let's just look at it. Now, the magnetic data of the table below was taken along a buried metallic ball and has been corrected for the top field target on the basis of the shape of the residual anomaly. Comment on the latitude of the location. Comment on the latitude of the location. So, here we have that x. This guy, just leave this. I'm going to come back to this table later. So, this is as a result of the calculation. So, this is the table that we have that's with the question. So we have the x and our observed data that we got from the field, okay, in nanotesla. Good. So the first thing you need to first find is the depth where our buried metallic ball is. So first of all, we have to first plot this data first. V against x. So V on the y-axis and x on the. So this is my scale. I use 2 centimeter representing 30 units for my y-axis, and I used 2 centimeter representing 20 units for my x-axis. Okay, you can just choose a scale that's okay for you. What else I used here? Okay, so after plotting, trying to join my points together. Okay, good. So see that now this data, it doesn't look like a residual anomaly. What you can interpret is a residual anomaly. Okay, the residual anomaly, because residual anomaly gives you it defines the anomaly, like the buried metallic ball, any buried magnetic source, the only one. In this data that were given, they've corrected for the geomagnetic field, the diurnal data, the circular variations and the diurnal variations. They've corrected for those ones. So the thing I'm going to correct now is we're going to do regional residual separation. I'm going to separate the regional from the observed. Our observed data now consists of both the regional and the residual. So we're going to move the regional and leave the residual. What did I mean by that? Now, if we talked about when we mention about the regional, now if you have something like this, can you see that? That's something like this. Now, depending on the kind of, maybe this kind of shape of ore, the gold ore that you have inside the soft surface. Okay, good. Or let's say iron. Let's iron. Okay, iron ore. Now, the residual is the magnetic field of the other part of the layer. Magnetic reading. Sorry, the regional, Jerry. Regional is the other reading. The reading of the surrounding. The reading of the surrounding. The readings that you are getting from the what? From this one. If this guy is not here, what we have in this place is something like this. Like it will be almost equal because it's the reading of the surrounding. Now, but because of the iron body, what happens is that we at this point it can either deviate depending on the latitude of the location. It can go up, it can go down, it can to choose the kind of shape. But because of the addition of the regional body on the residual of this guy, of our core field data, hmm, of our core field data, because of the addition of it to it, it will not, we cannot interpret until you have done regional residual separation. So always take note, you can't interpret until you've done regional residual what? Separation. Until you've done regional residual what? Separation. So now let's do regional residual separation. The first thing to do is to take a ruler and rule a line. Ensure that the ruler laps, I see, ensure that it laps on the first and the last point. That's my technique to it. Manually, laps on what? On the first and last. We can lap on other points too, but the first and last point is a must. So with this way, you can see it laps on the first two here, laps on the second two here, then you join together. We've joined our, this is what they call the regional line. The what? The regional line. Now, how do we get, the next thing we want to get is our what? Our regional data. Because for you to get our residual, for you to get our residual is equals to, residual is equals to observed data minus what? Regional. Observed data minus what? Minus regional. Data minus regional. So we are going to now extend each point. Hmm? Each point. Since this point and on this regional line lapse, it means both this guy to the y-axis have the same reading. It means this guy have the same reading, and this other one too that lap with this point has the same what reading. So it means that our regional in this place, let's say here is like minus 155 now. Let's say the observed minus 155. Because the point, hmm, and the line laps together, it means that what? Both your regional is also having that reading, which is minus 155. Now, if you have other points that doesn't lap with it, how do you get the reading of that point? Very easy and very simple. So for example now, let's say it is this point here. Hmm? I want to know what is the regional for this point here. What will I do? I will trace, can you see? I will trace from this guy upward, hmm, to this regional line. And I'll now get the answer for my what? For my y-axis. So this is my y-axis is raised by 33 units. So this is like 66. So I'll say in this point here, it is what? My regional will be what? Minus what? 66. Can you see that? Now, let's check on that one so that you'll be clear again. Now, if it's for this point now, I want to get the regional, you are going to do for each of the points one by one. If for this point, I want to do regional for this observed data. You will trace it also up. Immediately I touch it and check what is that reading. What is this reading on my inside? So that will be what? So you have something like this. This 0 be 3, 6, 9, 12, 15. That's what? Minus what? Minus 15. Good. So we did for all of that, and we now got, can you see? We got our regional residual, our regional data. These are regional data. Regional what? Data. You're going to do for all the points, regional data. But anytime the point and the line lapse together, by the first and the last, they will always have the same reading with your observe. The first and the last always have the same reading. If the second one also have the same reading, based on the way you rule your line, it will also be okay. My first two and my last two lapse with the line. So we have that. Now, let's look at something. After that, you're going to get your residual. How to get your residual is very easy. Residual is equal to observed minus what? Regional. Hmm? Observed minus what? Regional. You have to be mathematically smart. Residual, so minus 155, it is observed minus regional. My observed is what? Minus 155. My regional is what? Minus 155, have you? Can you see? So don't make the mistake of saying minus 155. So put the other one in brackets. So you have minus 155 plus what? 155, and that will lead us to what? 0. That will go to what? 0 here. Let's try for now. So it's minus 1 115 minus 96. Okay, minus 115 minus 96. So if we try to do that, minus 115 minus, because observe minus regional, anything minus then regional. What's regional? Minus 96. That's how give us what? Minus 19. So that's how we got our reading. Then after that, you're now going to plot your residual against your x. Residual against your x. So after plotting residual against